But yeah, thank you everyone for coming. Who's this first time here? I know there's a few. Oh wow, okay. Welcome. My name's Reese. I work for a company called Contino. I've kind of been setting up this continuous meetup for a couple of months now. Just noticed since I moved here, obviously I'm not from around here, but since I moved here, noticed that it wasn't really a continuous monthly meetup every single month, so I kind of just wanted to try and keep it going and get the ball rolling. So thank you everyone for coming, because if it wasn't for you, then definitely wouldn't be here. So we've got a couple of good speakers today. We've got Neal from Datto, and we've got the co-founding duo from XOps here, who are gonna give a talk as well. Usually it's pretty easy structure. Obviously everyone have a beer, have a pizza, then the talks, mingle, talk about, I don't know, your stresses of the DevOps world, or however you whatever problems you've come across, how you've overcome them, that kind of thing. But usually I invite people up at the start who want to make any announcements to the group, if they if you're hiring, or if anything like that, or if you don't know, if you've just got something interesting to say. Anyone, do you want to step up? Yeah, go on then.
Hi, I'm Dana. I'm representing Datto. We are currently hiring for multiple DevOps positions. We are looking for senior as well as associate, so if you know anyone or if yourself is interested, can work out of our Norwalk, Connecticut office. We also have a brand new Rochester office in Rochester, New York, and Boston, Massachusetts. So if anyone's interested, I'm back there. Come get a card. Thanks.
Cool, no worries. Anyone else want to say anything? No? No? Cool, all right. So I think we're going to start off with Neal giving his talk. What we'll do is, it's usually about 30 minutes, 45 minutes long, and then at the end, or you can go longer if you need, Neal, and then we just do like a Q&A at the end, and then same again with the chaps from XOps. So I'll hand it over to Neal. Cheers.
Thank you, Rise. Hello, my name is Neal. I am a DevOps engineer at Datto, and I'm here to talk about flexible, fast software delivery through our system called OBS, the Open Build Service. So to kind of start off a little bit, who I am, I consider myself a professional technologist. I've been using Linux for the last 15 years. I'm a contributor and a developer to a number of major Linux distributions, as well as several minor ones. I contribute and develop parts of RPM, the DNF package manager, various projects related to that. Obviously, DevOps engineer at Datto. And my contact points primarily through Twitter and Google+, and also my email address if you'd like to reach me by that. So to kind of understand how we got to OBS, let's start with the beginning. So in the beginning times, Datto, like most modern software development companies, develop on Linux. We use Linux for our servers, our client devices, things like that. And when we were first starting out as a company in 2007 and 2008, when we were making our first products, we didn't really think too much about how to make the software available on the devices and on the servers. It was more of an afterthought than anything else. So we kind of went the quick and dirty and admittedly somewhat route of doing zip archives of all the files and then pushing it onto the servers and calling it good. But then as we started changing the software and doing stuff like that, we needed a mechanism of being able to migrate databases, change configuration, things like that. And so, as it became more complicated to do these kinds of things, we wound up designing a system that we lovably call Check-in, which is a large spaghetti of on-demand pull services that will actually run arbitrary scripts and things like that on devices as well as on servers to handle configuration of these things. This is before the days of mass configuration management, I think Puppet was 2011 and Ansible was 2000 around that time as well. So this was before that particular time, so nobody really turned towards that because it wasn't a thing yet. This sort of started falling apart around the second time we tried to do a major distribution upgrade to rebase our systems. At that point, we decided that we were going to move towards using real software packages through the distribution mechanism. So we made the transition to proper-ish Debian packages for our stuff because we use Ubuntu internally for our servers and our devices. But of course, we needed a build system of some kind to do this. And we kind of put together a thing that we call, the Git hooks system, which did a mixture of push deployments as well as package deployments. And so the way that worked was it would just wire into things and then pull the code and make a deb and then just push it to the server and then do dpackage-i apt-get install-f and call it good. That worked okay until introducing Datto Linux Agent. Austin McCord announced at DattoCon 15, which was in 2015, 3 years ago, that we were releasing a Linux backup agent product. And that meant that we were going to support a whole bunch more things. There were a number of issues with the system at the time that we kind of waved away because we didn't really care. Dependent packages couldn't build against each other. We were restricted to only the Ubuntu distribution family. We couldn't even build Debian trivially. That was hard. And the setup was very fragile. We had to do crazy things like create users, open up space, and then set up the hook and do weird checkout things to make sure that the source code was always going to have enough space to build itself. The setup was very fragile. And it really didn't work because at launch, the Datto Linux Agent supported more distribution families than that. It supported Red Hat, CentOS, as well as Fedora, and Debian and Ubuntu, and there were plans to add OpenSUSE and SUSE Linux Enterprise at the time. Those eventually did happen, but at that time, we were talking about 9 distribution releases. And because it wouldn't work on the build system we had at the time, I was doing it myself manually for every single release. So the 1.0 release was me spending a week to do everything, validate it over and over. And within the first 2 months after that release, I was spending a great deal of time just doing that over and over and over and over. And it wasn't even my main job at the time. It wasn't something I was really supposed to be doing, but it had to get done, and I was the only person who really knew how to get it all working. And so I was doing it all the time, and it was killing me inside. I was going nuts, and it needed to get fixed. So, because the situation doesn't scale all that well when it's just me doing it, and if we add more distributions, I'm just going to croak. So I started looking into how to make this less burdensome for myself. So I started looking at different ways of automating it or systems out there in the field that would actually do this better. After looking at a lot of different things, there was a lot of people talking about custom build bot-based systems, Jenkins-based systems, random hook-like weirdness, stuff like that. I came up with 3 major alternatives to do this. The first one was really a build bot-based system where I would then modify the code to add dependency resolution using the Hockey library from the RPM, from the Fedora guys, and extend it to support Debian as well. The other alternative was that adopting Mock and Koji from the Fedora project and extending that to support Debian as well. That would have given me more or less the same kind of thing. Or use SUSE's open build service. And after a deeper examination and judging how much effort it would take for each of these, I elected to go with the open build service and try that. So why did I pick the open build service? It's a complete software solution that was made by SUSE to build their distribution. Because I'm a Linux distro developer, I tend to trust a lot of systems that are able to put together something at such a large scale reliably and reproducibly. And the interesting bit about the open build service is it was designed from the very beginning to support a wide variety of Linux distributions. And the reason for that was simply because SUSE first built AutoBuilder, the predecessor to OBS, as a way to build their distribution. And then as their business evolved towards enterprise and helping people get onto their platform, they added things like you want to migrate from Red Hat Enterprise Linux to SUSE Linux Enterprise. They offer support services, and they will provide you updates for you based on the RHEL packages that they've built themselves. And their OBS needed to be able to support that. And then they eventually also offered, through other migration strategies and things like that, being able to transport people from Debian or Ubuntu to SUSE Linux Enterprise for their customers. And so OBS eventually was extended to support all of these things. And that worked out really well for me, so I was going to take advantage of that. Yay. SUSE offers both a hosted system through the OpenSUSE build service, and that's freely available. You can use it and things like that, as well as an appliance image you can download from their website, openbuildservice.org, that you can use to set up your own system. And so one of the nice things that we had when we started using OBS was that It had several capabilities for integrating with version control systems and doing all kinds of interesting things to transform the code into something that's usable for built into production. Like it can fetch from the source code, it can analyze the code for like the necessary build it recipes, pull them out. Once it's done building them, it can fire off events to indicate that it's been built and then transfer it to like automated tests or review processes. And failures can also trigger notifications and all kinds of other interesting secondary pipelines. Some of the unique and interesting features, like this, as I was mentioning earlier about the transformation, officially under OBS, this is called source services. And it's a number of like little package scripts that you can install on your OBS system that when they're activated through a service definition in your package project, it will actually let you do scripted retrieval of processing of sources to actually do a build. One of the other nice things was that it auto scales based on what's available on the network for available workers. You can deploy workers trivially, like anywhere. You don't have to tell them where the master is. It will discover it and actually connect to it, and you will just grow your capacity just like that. It also has a lot of nice abilities for being able to speed up the construction of the build environments. Like if you've ever done package builds of particularly non-trivial packages, you tend to notice that the build route setup gets to be very, very long because it has to get all the packages, install them, set up the base environment, and all those things. OBS can do it once and then compress all of that into an archive that it holds in its cache, and then every time something requests something that matches to that, it will just extract it again and use that instead of having to redo the whole process over and over and over. And because it has its own integrated dependency resolver, it will check if there are updates for the pre-install images, and it'll actually just rebuild them for you. And so you don't have to do anything to keep those up to date. It's very nice. And as a consequence of having a dependency resolver, when you build something, it'll actually check the reverse dependencies if they're in your OBS, and it'll actually rebuild them for you. So like you can always make sure that your links are actually working. Like if you have binary dependencies across each other, it'll actually rebuild the reverse dependencies so that everything will actually work in the end. And it'll auto-increment the release, make sure everything's upgradable, does all the nice things for that stuff. It has fully customizable build environments. You can tell it what kinds of dependencies are allowed, which ones can be ignored, how to order them in case there's cyclic dependencies. You can even tell it what kind of build environments do you want. Do you want virtual machines? Do you want emulated foreign architecture machines? Do you want containers? Do you want just plain cheroots? Are you going to have remote systems? Are you doing cloud ones? Whatever. So how do we use it at Datto? So we use the official appliance provided on the website in an all-in-one configuration. So our master and our worker are on the same box. We don't really typically need to have more capacity most of the time, so it works out okay. So the appliance runs in a virtual machine without nested virtualization, so we fall back to containers. And we primarily target Ubuntu for most of our software. As I mentioned earlier, we use Ubuntu on most of our products and solutions. However, all of the software is built using RPM spec files. And that means that we use the RPM spec to build and validate against all the distributions that we want to target. We do this because OBS has a spec-based builder engine as well as support for a tool called debbuild, which actually will take RPM build-like inputs and produce native Debian packages that work and comply with Debian policy. And so we use this so that we can speed up our processes for being able to get people up and going with packages, because RPM spec files tended to be much simpler for people to grok than the Debian source control format. And we were able to produce native Debian packages for most people, they were able to grok it and get going all by themselves in less than a quarter of the time that they were doing it before. So that was a big win for a lot of projects. Our current system is actually holding over 400 packages across nearly 220 projects, producing 650 repositories. The last time we did a mass rebuild, which was actually 2 years ago, when we were preparing to upgrade our client platform from Ubuntu 12.04 to Ubuntu 16.04, which was a very big change. Literally everything had to be rebuilt. Lots of things had to be reworked. The mass rebuild took 5 hours, roughly, across 6 builders on 1 machine. So we managed to take care of all of that in pretty much less than a day after all the integration was said and done. Most projects target at least 2 distribution families and produce native packages for both using the same spec file. So we tend to a lot of projects tend to have the spec file build for both Ubuntu, which is our production target, and they'll also build for like either Fedora or CentOS, depending on the developer's preference on what they're using. A lot of developers internally use Fedora because we actually let people choose what Linux distribution they can run on their computers if they're going to run Linux on their workstations. And a lot of people prefer to run Fedora or CentOS. Some people choose OpenSUSE as well. And so they tend to choose two targets. And those also help with validating the correctness and the portability of the software. So a lot of people tend to appreciate that that's really easy to do. And the Datto Linux agent, as I mentioned earlier, is built for 24 distribution targets today and is actually actively supported on almost all of them. Some of them are end of life, so like we've kind of just stopped supporting them because the distribution itself is end of life. And number 25 is coming soon. Fedora 28, which will release sometime in mid to late May or early June, we will support it on day one because we have been able to meet every single Fedora release on time. We have actually been able to test and validate it before the distribution has even been released because OBS allows us to be that quick about it. And so I'd like to show you just a little bit about this right up front. So here I've got a project here that's it's Microsoft's proc dump for Linux. They released an open source minimal tool that's based on the sysinternals proc dump. If you're familiar with Windows stuff, they made a Linux version for it, and I decided, on a whim, I'll just package it up, this way. It comes in very handy. It's a very lightweight tool. The spec file itself is not all that complicated, so it's just, there's two conditionals. One to define the Debian group there, and the other one here is to define the build requires, because it's slightly different on Debian versus everything else. Oh, is it too small? Sorry. That better? Yeah. Excellent. So let's scroll back up here. So there's the group over here for the Debian one, and then we have the build requires over here, for the Debian-based one, and it's just your standard spec file. Otherwise, looks basically pretty plain. And then that built for CentOS, Debian, Fedora, Magia, OpenSUSE, and Ubuntu. All of them natively. And so if I pop in and look at say Ubuntu 18.04, which I actually just turned on 30 minutes ago. And so that 18.04 target, it sets up the build environment. It ran through it, and yeah, whatever. All the weird things about 18.04 is not released yet, so there's all kinds of weird things going on there. Well, people try to sort out how to make that one work. But it eventually does actually build it. It runs deb build, executes the spec, and actually builds it properly. Compile flags, debug symbols, the works. And it produces the debs and stores it. And it produces a Debian repository that you can actually use. So if I go to, download package over here, if it will load. So I can choose CentOS or Debian, Magia, Fedora, Ubuntu, and you kind of get the picture. So it supports all of these guys just out of the box, and it was able to build it pretty well. But the other nice bit is that it's actually pretty easy to set up. This is what my project, my meta configuration that describes what are my dependency trees that I'm actually going to be dependent on for making this package build. So you can see there's the deb build project and then just the straight up distribution. And so that's a product definition there. And then here we have an appliance image that I'm building using OBS's image building capabilities using a tool called Kiwi, which is SUSE's multi-distro, or rather distro-agnostic image building tool. It can produce ISOs, it can produce USB stick images, it can produce VM images, it can produce containers, whatever you want. So I just set this up to be a really simple appliance image. It's just going to produce a VM that's VMware compatible, and then it built the thing. It runs through the process of actually setting it up, and then creates the image at the end. And then if you want to get it, there it can be downloaded from here, and you can use it from there. And this is actually all available in both the hosted version as well as your on-premises one, because you just get this stack right out of the gate. So aside from Datto, obviously, there's got to be other people that use it. And really notable users are like OpenSUSE and Pacman. That's part of the OpenSUSE community. You think of Pacman like that third-party repository that provides all the extra stuff that OpenSUSE proper can't ship for various reasons, software patents or whatever. Mare and Tizen are Linux distributions that are focused on mobile devices primarily. Mare is for the Sailfish OS by the Jalla guys up in Finland. And Tizen is actually a project that's mainly run by Samsung, spearheaded by the Linux Foundation. Linaro is a group that is, under the auspices of the Linux Foundation and several other organizations that actually handles and promotes the usage of Linux on ARM, and they build a lot of their stuff with an OBS. And Dell and Videoland both have private instances of OBS, and they publish those projects. They publish the outputs publicly for people to use, and they acknowledge their use of OBS as well. Collabora is one of those other consultancies. They primarily focus on Debian, so they're not really working with anybody else on any other distributions, but they use OBS as well because they acknowledge it's a fantastic technology for being able to get these kinds of things done really quickly and really well. So yeah, in conclusion, OBS is awesome. And if you're interested, we're hiring, and you get to maybe work with me and all of the cool OBS stuff that I do. And another little bit that I didn't really mention on the slides, we actually wrote a small little wrapper tool for integrating with our GitLab CI-based system that we call, rather plainly, OBS CTL. And if there's some interest in it, we were thinking about open sourcing it and bringing it out to the world for other people to be able to leverage, use, and contribute to. And it's actually very much centered around our workflow of using spec files for building natively across all these different distribution targets. We do pre-production scratch builds and things like that we test in CI on every commit, on every merge request, and things like that. So we have this interesting workflow that we've built to augment the nice capabilities of both the build system as well as our version control system. So, there's some references if you want to check out the website for the Open Build service where they got a lot of great information there. And, if you want to just kind of poke around, I highly recommend you just set up an account on the OpenSUSE build service and just do stuff. It's free for anyone to use. Just sign up for an account and go for it. And the Open Build service documentation over there and the DevBuild project, if you're kind of interested on hacking on it, be warned, it is Perl. So, there's that. But other than that, it works great. So, yeah, do you have any questions? Sure.
Explain to me the difference between the OBS and something like Jenkins or Hudson.
Okay, sure. So, Jenkins, Hudson, BuildBot, all of those guys, they operate on the principle that each package is more or less self-contained and that they operate by themselves. And they make the assumption that you're kind of bundling the world, you're not really working with other things, you don't have really dependency relationships and things like that. So in many cases, what's going to happen is that unless you explicitly define the pipeline, so it just doesn't discover it, it's going to just build itself and be done. This becomes a problem when you start having arbitrary consumers of things. So for example, one of our internal projects is producing a library for making an enhanced transport mechanism for sending large gobs of data over the internet. Well, we don't know who's going to use all of that, but they're all they're all building in our build system. So as long as they're all interconnected against that main project that produces that package, anytime that library gets bumped, every dependent project gets rebuilt automatically and everything publishes together. So in the end, we always get a fully working combination of packages. And nothing will publish if nothing is working. So that's sort of the value here because we get to avoid those kinds of nasty problems that a lot of people say dependency hell and crap like that. Generally speaking, OBS more or less solves that problem. It also makes supporting tons of Linux distributions really easy. I know a lot of companies struggle with supporting more than one Linux distribution, but we have managed to make, with what we have done, we have managed to make it possible to support 25 Linux distributions trivially. That's not a small feat. And frankly, I think it's awesome because we make our products available to more people across more configurations in more workloads, and it just makes everyone happier. Except for maybe the poor guy who has to think about everything. But, most people don't have to think that hard because it all just kind of works. Any other questions?